Students, today's topic is normal distribution. You have already seen what a normal distribution is. This video is in continuation with the earlier one which you have on normal distribution. Here we will be mainly concentrating on how to analyze phi of z in terms of the normal curve. Now, as we know, the probability density function for f of x is given by f of x equals 1 upon sigma root 2 pi e raised to minus x minus mu whole square by 2 sigma square, where sigma stands for the standard deviation of the distribution and mu is the mean of the distribution. X lies between minus infinity to infinity, mu lies between minus infinity to infinity, and sigma should be a positive quantity. Now, the probability of x, this is called as normal variate, x is called as a normal variate. The probability of x lying between a and b is given as 1 upon sigma root 2 pi a integration a to b e raised to minus x minus mu whole square by 2 sigma square dx. Now this integration cannot be evaluated by the known methods. We have to employ the technique of numerical integration, which becomes very tedious. So hence we need some other way to solve this. So for this purpose, what we do, we standardize it in the following way. We substitute z1 as a minus mu by sigma and z2 as b minus mu by sigma. Then the probability of x lying between a and b, the earlier formula, becomes 1 upon root 2 pi integration z1 to z2 e raised to minus z square by 2 dz. Hence, the normal variate x has been converted into a standard normal variate z using these two substitutions. Therefore, the formula now becomes 1 upon root 2 pi integration z1 to z2 e raised to minus z square by 2 dz. Further in particular, if I put z1 as 0 and z2 as z, then the equation is, formula is 1 upon root 2 pi integration 0 to z e raised to minus z square by 2 dz, and we call this value as phi of z. Now this represents the area under the standard normal curve from z equals 0 to z. The physical significance of this phi of z is, it is the area covered by z from 0 to z. Now this is called a standard normal curve. This is a bell-shaped curve which ranged from minus infinity to infinity. X ranged from minus infinity to infinity. Phi of z means the area shaded here. Your x should range from 0, z should range from 0 to z. Now we can see that this is a symmetric curve. Now since the sum of the probabilities is 1, the total area covered by this curve is also 1. Now since the curve is symmetric, this from 0 onwards to the minus infinity, the area covered by the curve will be 0.5. Similarly, this area from 0 to plus infinity will also be 0.5. Now tabulated values give the area for different positive values of z. Now let's see, later we will tell you how to see the table for finding the values of phi of z. Now how do we interpret phi of z? Interpretation of phi of z in terms of these curves. Let's see, we want to find probability of z lying between 0 to 2. We should remember that z is a standard normal variate, whereas x is a normal variate. If x is given, we need to convert x into z and then imply to this curve. Now probability of z lying between 0 to 2 is viewed like this, 0 to 2. Now on the left hand side you have the negative quantities, on the right hand side you have the positive numbers. So 0 to 2, I will shade this area 0 to 2. So this area is phi of 2. Now probability of z lying between minus 2 to 0. So this is minus 2 to 0, shaded portion. So this can be written as probability of z lying between 0 to 2, because magnitude wise, since the curve is symmetrical, whether the area is on the left hand side of the curve or the right hand side of the curve, the magnitude of the area for minus a and a will be same. So probability of minus 2 to 0 is same as probability of z lying between 0 to 2, and this I will be calling as phi of 2. Let's see, probability of z lying between 3 and 2 or 2 and 3. Now we can see this is 2, this is 3. So we are talking of this area. Now how to calculate this? Now the right hand side of this curve is totally 0.5 and left hand side also is 0.5. Now let's see this right hand side only, but I am interested in finding only this shaded portion. So how do I understand this? I'll write it as probability of z lying between 0 to 3 minus probability of z lying between 0 to 2. This unshaded portion has to be subtracted from up to 0 to 3 so that we can calculate this shaded portion. So I can write this as probability of z lying between 0 to 3 minus probability of z lying between 0 to 2. So this can, in other words, can be written as phi of 3 and this is same as writing phi of 2. So this shaded portion is phi of 3 minus phi of 2. Let's look at this. Probability of z lying between minus 3 and minus 2. So this is minus 3, this is minus 2. So I will write this portion as, I need not worry about this right hand side of the curve. We will just see the left side of 0 here. So I can write it as probability of z lying between 0 to minus 3 minus of probability of z lying between 0 to minus 2. Why I am using this minus is, I don't want this unshaded portion. So this can be written as probability of z lying between 0 to 3 because magnitude wise it does not affect. Minus probability of z lying between 0 to 2. So it is again same as saying phi of 3 minus phi of 2. So if the portion is same, if the values are same for A and B, whether you do it on the right hand side or on the left hand side, the magnitude of the area will be same. So this is phi of 3 minus phi of 2 again. Now let's look at this. Probability of z lying between minus 1 and 2. So this is minus 1 and this is 2. So we are interested in finding the area of this shaded portion. So how will I write it? Probability of z lying between minus 2 to 0 plus probability of z lying between 0 to 2. Now minus 1 to 0 can be written as 0 to 1 plus this is 0 to 2. So we know that probability lying of z lying to 0 to A is phi of A. So this is phi of 1 plus phi of 2. Let's look at this curve. Probability of z lying between 0 to infinity. Now z 0 to infinity, that means this whole positive side. So as we know, the area of this is 0.5. So phi of z in this case is 0.5. Similarly, even if I take z lying between minus infinity to 0, this portion, that is also 0.5. Look at this. Probability of z lying between 4 to infinity, or we can say probability of z greater than or equals 4. So greater than 4. So this whole portion will come. So how can I express this? We can write it as this whole thing 0.5 minus this 0 to 4 portion, this unshaded portion. So I will get this as the area of the shaded portion. So it will become 0.5 minus phi of 4. Now this one, probability of z lying between minus 1 to infinity. So minus 1 to infinity. So all this area. So how can I write it? Probability of z lying between minus 1 to 0 plus probability of z lying between 0 to infinity. So this 0 to infinity is 0.5 and this is same as saying 0 to 1. So the total area becomes phi of 1 plus 0.5. Let's look at some questions based on this. Evaluate probability of z less than or equals 3. So less than or equals 3. So I will be shading this side portion, less than or equals 3. Now how can I write it? Minus infinity to 0, 0 to 3. So this half portion is involved in that. So this is 0.5 plus this is phi of 3. Now phi of 3 can be looked from the table, normal table, and that value is 0.4987 and hence 0.9987. Now this one. Probability of absolute value of z less than or equals 1.94. That means z lies between minus 1.94 and plus 1.94. So in terms of probability, I will write it as z lies between minus 1.94 to 0 plus z lies between 0 to 1.94. So again, this is phi of 1.94. This is also phi of 1.94. So twice of phi of 1.94 from the normal table. Phi of 1.94 is 0.4738. So 2 into 0.4738 will give us 0.9476. Now how to look at this table? Suppose we want to see what is 0.67, phi of 0.67. So first we should vertically look 0.6 and then go for 0.07. So intersection value is 0.2486. So phi of 0.67 is 0.2486. Let's say we want to see phi of 1.23. So we'll see 1.2 here and 3 horizontally. So the intersection value is 0.3907. So phi of 1.23 is 0.3907. One more, phi of 0.5. So 0.5, and then I will look for 0 horizontally. So the intersection one is 0.1915. So phi of 0.5 is 0.1915. This is how we read a normal probability table. Let's look at this question. If x is a normal variate with mean 12 and standard deviation 4, find probability of x greater than or equals 20 and probability of x less than or equals 20. Now here x is a normal variate. We need to convert it into standard normal variate so that I can use the curve. Now it's given mu is 12, mean is 12 and standard deviation sigma is 4. So when x is 20, z needs to be calculated. Z is x minus mu by sigma. So 20 minus 12 by 4, which is 2. So probability of x greater than or equals 20 is same as saying probability of z greater than or equals 2. So this is greater than or equals to 2 area. This I have to find. I need not worry about this left side position. On the right hand side, this whole area is 0.1, 0.5. But I am not interested in this blank portion. I am interested only in the shaded portion. So I will write it as 0.5 minus phi of p of 0 to 2. So that is phi of 2. Hence it becomes 0.0228. Now probability of x less than or equal to 20 is same as saying probability of z less than or equals 2. So this is the shaded portion. So this much shaded portion is 0.5 and this is 0 to 2. So 0.5 plus probability of z lying between 0 to 2. So that is phi of 2. So phi of 2 can be looked from the table and hence the answer is 0.9772. Let's see one more question. In a test of electric bulbs, the lifetime of a particular brand was distributed normally with an average life of 2000 hours and standard deviation of 60 hours. If a firm purchases 2500 bulbs, find the number of bulbs that will last for less than 1950 hours, between 1900 and 2100 hours. Solution. Now this is given that it is a normal distribution question and average life mu is 2000, standard deviation is 60. Now here our x is, for the first part, our x is 1950. I will convert this into standard normal variate. Z equals x minus mu by sigma. So it gives us minus 0.83. So probability of x less than 1950 is same as saying probability of z less than minus 0.83. So from our shaded portion, it is like this. So I can write it as 0.5 minus this quantity, which is phi of 0.83. So hence I get 0.2033 number of bulbs out of this 2500. So number of bulbs will be 2500 into 0.2033, which is nearly 508 bulbs. The second part, x lying between 1900 and 2100. So if we convert this 1900 and 2100 into z, we are going to get minus 1.67 and plus 1.67. So probability of x lying between 1900 to 2100 is same as saying probability of z lying between minus 1.67 to 1.67. So we can write this as minus 1.67 to 0 plus 0 to 1.67. So again this is phi of 1.67. This is also phi of 1.67 to phi 1.67, so it is 0.905. So number of bulbs which last between 1900 to 2100 hours is 2500 multiplied by 0.905. So which gives us roughly 2263 bulbs.